to this stream of the H3 launch vehicle, which is Japan's next vehicle, which is hopefully going to be a little bit more efficient than their previous vehicles, and also critically able to compete with the Falcon 9, which is of course kind of the king of launch vehicles right now. A little bit introduction into who I am. I'm Josiah. I'm the chief engineer at a student rocketry group called Astra, and we are operating out of Bremen. And we're composed of a bunch of students that come from the universities in and around Bremen. And we have a mission of trying to launch a rocket to space, which is a fairly ambitious mark for student rocketry teams. There's only actually one team in the entire world that's done it so far, so we're trying to be number 2. And we're hoping to be the first one to build a hybrid rocket that does it. And a little bit of an Easter egg, on my shirt right now, we have the design of the nozzle for our last rocket called Karma. It's the one that we were testing and building last year. There might be a couple of things about our group as we go through the live stream of this rocket, and hopefully we learn some things from the professional launch community, and maybe you'll learn a little bit about what Astra's about, and also hopefully about this new cool launch vehicle, because there's lots of interesting things that are making it hopefully quite competitive. So we're about just over an hour away from launch. We are a little bit lucky because we actually get 2 views of the launch vehicle today. There's going to be one that's coming from a fixed camera that's a couple of kilometers away from the launch facility in Japan. And we also have an official live stream which Jaxa is hosting. Now, Jaxa, of course, is going to host the stream in Japanese, so if you're not a Japanese speaker, it may not be clear exactly what's going on. They do a little bit of English here and there, but hopefully I'll be able to kind of supplement the information that they're giving. I don't speak Japanese myself either, so keep that in mind. Looks like we're getting an ad here. What the heck? I'm not sure what that's all about, but okay. Yeah, so the stream will be in Japanese, of course, so but there'll be parts of it that are in English as well, so we'll be able to see a couple of things. But I'm also going to be sharing a lot about the design of the rocket and a little bit of the engineering side of things and what makes this rocket special, and maybe in the future able to compete against the, of course, the Falcon 9. So maybe we go into a little bit about the rocket. We're going to stay tuned for when that live stream starts up, and we'll probably be switching to it. But before we go into that, we might want to talk a little bit about the launch vehicle and what we expect. If you're just joining now, we are just over 1 hour away from the launch of the H3. It's going to be launching at, it's for me, 1:22 a.m., which I think is, that's 1:22 on Saturday morning, but it's on UTC, that's actually Friday evening at 11:22. But don't get confused by the timings. It's going to be in roughly an hour. So, to talk a little bit about the H3 family, it's going to be a whole bunch of vehicles that are possible with this rocket configuration. Today, they are going to be launching, I believe it's the H322S. So, you can kind of figure out how the rocket is configured based on the numbers that are behind the dash of the H3. So the first digit is telling you how many engines are on the core stage. That's the yellow looking stage in the middle there. The second number is telling you how many boosters are going to be strapped on. And the third number tells you how long the payload fairing is. So with those 3 things, you can figure out what type of vehicle is being launched. So today it's the H322S that we're going to be launching. To give you a little bit of an idea about the statistics for the vehicle, and if you want to kind of put in your mind the size that you should be expecting, because they all kind of look the same when you're looking at them from afar, right? The height of the vehicle is 63 meters, so a Falcon 9 is 70, so it's just a little bit shorter than a Falcon 9. The main diameter of that core stage is 5.27 meters, which is actually quite large. It's bigger than a lot of other vehicles that are in that weight class. But there's a reason for this, because the vehicle is running on hydrogen, and hydrogen is notorious for being super light and not dense at all. So it takes a lot of volume to to put a bunch of mass into a single space. So rockets that use hydrogen tend to be bigger in volume, and that's what's happening here. It has a payload capacity of around 4 tons to low Earth orbit. That's using its base configuration, the 22S version. If they want to go to geotransfer orbit, if they put the biggest rocket they possibly can, which is I think the 24L, I think they can do even more than what's listed here of 2 to 3 tons. I think they can get up to 4 tons with that configuration. So this puts them actually quite competitive against the payload capacities of the Falcon 9, because the interesting thing about the Falcon 9 is that it can't actually maximize its payload tonnage unless you have a very specific payload, right? So this is where the H3 is going to be able to compete, because it actually has a bigger payload fairing, and that's because it has more space. The diameter of the vehicle is actually 5.27 meters, which means that it has a wider payload fairing at the top, which means that it can kind of fit for some bigger payloads which need more volume and space in order to be configured onto the launch vehicle, which is actually more of the driver that causes that payloads want to have. They're not usually taking up a bunch of mass. They're usually taking up a bunch of volume. So in reality, although the Falcon 9 does have more payload to orbit capacity in terms of mass, it can never take that mass inside of its payload fairing. It's just too small. So in that way, it's kind of a badly designed vehicle. I'm speaking of the Falcon 9. So the H3 is kind of a better design in that respect. But yeah, we'll talk more about that and why that's interesting as we go here. Maybe we just switch back to the live view and see what that's looking like right now. Okay, I guess we have to watch the mandatory ad. My goodness. Okay, so here we have a live view of the launch vehicle. So it's right now it's just sitting on the launch pad. It's going to be launching in about an hour. And it looks like here comes our live view here. So this is going to be the live casting. This is one of them. There's also another one here. I think we're going to watch this one though. I think this is going to be the one to watch. This is the official stream. So let's make this one big. So the entire stream is going to be, at least most of the stream I expect is going to be in Japanese. So I'm hoping that I can supplement the information a little bit in English as to what's happening. So just to give you a little bit of a rundown of the history of where this mission is and what's going on. H3 is the next development for the Japanese space program of a vehicle which can basically be the main launch vehicle for all of their payload needs. Before they had the H2 rocket, which was quite prolific. It's launched tens of times, maybe even hundreds, I don't know. It's like a workhorse rocket for the Japanese. And this is going to be like the next rocket that they're going to want to be relying on. They've been developing this thing for many, many years. I think it's over 10 years now that they've been working at it. So it's been a long time coming. And if you remember, last year, right around this time, I think it was in February as well, they actually attempted to launch the rocket, but they had a problem. And it turns out that something was wrong with the ignition process. The main rocket on the center core stage, the liquid rocket, it ignited just fine and was actually burning for many seconds. But for some reason, those two solid rockets didn't ignite. And so the vehicle was just stuck on the pad because it needs those solid rockets in order to have enough thrust to get off the launch pad. The liquid rocket is running on hydrogen and liquid oxygen, which those engines don't usually have a lot of thrust to weight. So it actually can't lift off by itself in the configuration where it just has two engines. However, obviously there was some more things they wanted to fix and some things they wanted to tweak, because obviously it took them a whole other year to get back to the launch pad. So we're hoping to see that the improvements have been worth it and that finally this will be the day that we get to see this thing fly. And here you see they have a model of the rocket there. So this is the rocket in the H322S configuration. So the first 2 is indicating how many engines are on that core stage. The second 2 is indicating how many solid boosters are strapped to it. And then the S is just indicating how long the nose payload fairing is. So that gives you kind of a good idea of the scale of each of those pieces. Yeah, so as the rocket takes off and goes to orbit, you're going to see those 2 side boosters are actually going to separate after about 100 seconds into the flight. And then that core stage is going to take it a lot of the way. And then it's actually going to separate, and there's going to be a second stage, and it's the part that's in the lighter colored yellow, not the deep colored yellow. The very top and the lighter colored yellow is going to break off, and then the second stage is going to take it all the way the rest to orbit. And just to give you a bit of an idea of what the rocket's running on, right now the core stage is running on hydrogen and liquid oxygen. This is actually the most efficient fuel that you can have, at least for modern purposes. It gives you a really high specific impulse, but the cost that you have is, of course, you have to deal with hydrogen, which is a really low mass, really high volume substance, so you end up getting kind of a wider body. But that's not exactly entirely a bad thing, especially for the purposes that the H3 rocket is going to be launching for. And then, yeah, of course, those 2 side boosters are solid rockets, so they're just using solid propellant. Once you ignite them, you cannot stop them. So once they start going, they're going, and there's no stopping. It's not like a liquid rocket where you can like throttle it and turn it off, turn it on again. It's just go or not. So yeah, maybe it was actually a good thing that they didn't like the solid rockets last year, because if there had been something that had gone wrong, it probably would have gone wrong in a much bigger way. Yeah. So here you see some of their goals that they have for the rocket. Of course, they're trying to make this be a vehicle that can compete in the modern launch environment. So I think the key things you have to look out for in those situations are, of course, cost. You want to get the costs down. So they're trying to make this a very cost-effective rocket. And if you look at the actual sticker cost of the vehicle, it's only $50 million for a launch, which is interesting, because that means that it's actually cheaper than a Falcon 9. Because Falcon 9s go for, I think, $65 million now. So it's actually $15 million cheaper than a Falcon 9, and can potentially do a lot of the payload missions which the Falcon 9 is responsible for. So it can kind of maybe do some of the same missions that the Falcon 9 gets contracted for, but it can do it at a lower cost. So that's kind of an interesting idea about how the H3 rocket might be able to compete. Hey there, Failspace. Nice to see you. Glad you could join. Hope you're excited as we are to see this H3 rocket fly. So yeah, I expect that right now they're probably in the filling process. It takes a long time to fill a rocket when it's made when it has hydrogen in it. So keep that in mind. They probably started filling it like 2 or 3 hours ago. Another interesting thing about that is that they have to keep the liquid hydrogen cold, right? Hydrogen is liquid at like 20 Kelvin, which is minus 250 Celsius, which is like incomprehensibly cold. And because of that, they need to be continuously filling the vehicle all the way up to launch. So I think that if you get some zoomed in shots of the vehicle, you'll start to see things like vapor clouds and stuff like that on the vehicle, which are indicating that it's getting ready for flight. Yeah, I agree they should do an English stream, but they actually kind of have a cool strategy where they kind of intermix the English with the Japanese, and you'll see that in like the last 10 or 20 minutes. They'll start switching to English sometimes, because they do want to reach kind of a more mainstream audience a little bit, I think. But of course, it's a Japanese space agency, so it makes sense that they would stream in Japanese. I kind of like it better the way that the Indian Space Agency does it, though, because they kind of do it 50-50. So they stream, and they do it pretty seamlessly, where they're switching between English and I think they do Hindi is the other language they speak typically. But yeah, doesn't detract from the quality of the launch though. Japan has a rich history of developing very impressive launch vehicles, and also developing vehicles which are very efficient and low cost. They actually notoriously have the lightest rocket to ever be launched to orbit. I think it's only like 2 tons that the rocket is when it's fully fueled on the launch pad. Yeah, just a little tidbit. Some of the cool stuff that they develop in Japan is quite impressive. So Tom is asking, what do I think about Starlink risks and Kessler? I'm assuming you mean Kessler syndrome. That's when basically orbit gets so clogged up that you can't really launch anymore because things start hitting each other and making more debris, and then those pieces of debris hit stuff and makes even more debris, and then eventually you just have a big, huge debris cloud that's just surrounding the Earth. Yes, that's a risk, of course. And as we start to launch more and more satellites into orbit, you're increasing the risk that happens. Of course, you probably know that Starlink is launching like tens of thousands of satellites, which is unprecedented, really. If you looked 5 years ago, there was probably only a couple thousand satellites in orbit at any given time. But now, if you look at today, we already have like 5,000 Starlink satellites that are up there, and they're going to put double or triple more of that to fill up their constellation. So obviously that's really increasing the risk of Kessler syndrome. But it's important to note that the Starlink satellites are actually quite advanced in that they kind of know where each satellite is, so they can kind of reposition themselves depending on the trajectories that they expect to be on. So if they're going to hit each other, they just kind of move out of the way. So even though there's lots of them up there, they're actually really good at being able to navigate. And as soon as they are not able to navigate, or they're about to not be able to navigate, they can just quickly be deorbited so that they're not going to be in the way and cause problems. And so far, I don't think Starlink satellite has ever hit anything yet. So I would say that in general, the advancement of satellite constellations will mitigate the risk of Kessler syndrome. And there's just going to be more regulations that are going to require all the satellites to behave in this way, where they can just almost automatically react to things that might be in their way. Yeah, I don't really think it's going to be that big of a problem, to be honest. They are a little bit annoying for seeing them in the sky, because astronomers, of course, want to have a clear sky when they take a picture. And if you do a long exposure and you have like a satellite track going through your image, obviously that can be incredibly annoying. But yeah, I think Starlink's trying to work with some astronomers to figure out how they can think of solutions for things like this. Yeah, anyways, I don't think that the H3 is going to really contribute to this problem too much. Obviously it's going to lift stuff into orbit, but I don't think it's going to be quite on the scale of Starlink type constellations. That's not really what the vehicle is designed for. It's more designed for payloads that are kind of unique. So things that space agencies might want to launch, or maybe specific type of Earth observation satellites, or things like this, where you kind of have a niche kind of payload that you would need to have a dedicated vehicle for, but you don't need to cram as much mass into a payload as you possibly can. That's kind of what Falcon 9 is good for, just taking a bunch of stuff and just putting as much stuff as you can put into there, and then launching it. It's quite efficient in that configuration. So let's see, fail space. Yeah, if Starship starts launching reliably, it has to launch reliably. Obviously, that's going to drive rideshare prices down. Although ride sharing is going to be an interesting concept on a Starship type vehicle, because you have to think that Starship has such a high payload capacity, like on the order of 100 tons. So to fill that capacity would require you to have 100 tons of payload worth to launch. And I don't think the small sat rideshare global network right now even would add up to one launch vehicle of a Starship per year. So there would have to be a lot more availability for that type of payload for Starship to really take advantage of it. But maybe if the prices are a lot lower, more people will be able to participate, and that's where it gets interesting. So like maybe if we right now a small satellite, will cost you somewhere between like 500,000 to like $1 million to launch as a rideshare. But if you get that cost down to like less than 100,000, maybe that's going to cause more people to be able to participate, and then you're going to have like more people like, I don't know, maybe even universities and student teams and companies that want to do startups for various reasons where there's an inhibition because the cost of launch is so high, but now that it gets cheaper, maybe it gets easier to have more economic development. I don't know. If Starship starts ride sharing in a serious way, I think it's going to be pretty bad news for things like the H3, to be honest. It's going to struggle to compete. But that's a future thing. H3 is now, and if it gets to orbit now, it'll at least be able to compete against the Falcon 9, I think. What do I think about the current position of Europe in the space science economy? Well, here's an interesting statistic. I'm currently I'm compiling a video right now about the student launch rocketry community and about all the groups that are trying to get to space right now. And of all of the groups in all of the world, half of the groups which are actively pursuing launch vehicles which will go to space in student rocketry and amateur student rocketry, half of them are from Europe. So this makes me actually a little bit positive about the future of the European space science community and the economy for that, because the engineers that are able to do the things like build vehicles like the Falcon 9 and cool things like that are able to compete on the global scale are the ones that come out of these groups. So I think that Europe is doing a better job in the last 5 or 10 years of focusing on building those grassroots groups that are able to then develop students who are then able to get skills and then take those skills into the economy, and then that starts to build the space economy. So I'm kind of hopeful in that respect. Although I still have to admit that right now, obviously the space community still lags behind the US, especially on the launch market. Of course, the launch cadence for European vehicles currently is 0, which is not good. The Ariane 5, of course, retired, and the Ariane 6 is still not launching. So, yeah, there needs to be more than just Ariane in the European launch community. That's important, because it's not the only one, Yeah. Hopefully, there are some new groups that are coming up. Like there's 3 launch companies in Germany right now, and they're all trying to get a launch vehicle going soon. There's Rocket Factory Augsburg. What's it called? High Impulse. There's one other one I'm forgetting. It operates out of Munich. It's escaping my mind right now. But these companies are going to be launching to orbit probably relatively soon. They've been saying next year for the last 5 years, so sometimes it's tough to tell, but I think by 2027, 2028, they're definitely going to be operational. But they won't be. They will have trouble competing against vehicles that are in the market at that time, I think, especially things like the Starship, and yeah, some other ones like, I don't know if New Glenn ever comes online. That'll also be tough to compete against. Yeah, we'll see. Yeah, there's also the Asian launch market that'll be competitive, I think, at that point as well. Like, India is going to have all kinds of competitive launchers. They're already competitive as they are right now, but there's also private companies there that are trying to develop even cheaper launch vehicles. And of course, there's ones like the one we're going to see today, hopefully, the H3, and whatever the evolution of that is, because obviously this is not going to be the end for Japan. They're going to probably keep developing. I'm hoping they're thinking of moving towards a reusable vehicle, because right now the H3 is still not reusable, and you're going to see that today. Like, it expands all the parts of its vehicle. It can do it very cheaply because they have kind of a clever design about how they're going about it. But as we see Starship come online, and it becomes clear that okay, reusability is kind of like critical. Otherwise, you can't compete against this launch vehicle. I think that's going to force everyone to kind of switch to those types of things. Yeah, what do I think about shuttle concepts? It depends on the shuttle concept. You mentioned Dream Chaser. That's not really a shuttle concept, to be completely honest. It's more of a space capsule, because it needs an entire launch vehicle to get into orbit. So like, you basically put the Dream Chaser onto a launch vehicle like the Falcon 9, and then you launch it into space, and then only then is it like a dedicated vehicle, and then it flies back. But that's the same thing that a space capsule does. So I don't really see that as really a shuttle concept. They're not reusing any like launch hardware when they do a Dream Chaser launch configuration. So I think that just adds complication for no reason, because you could just build a space capsule, and those are far more reliable and work a lot better. The only advantage you get from the Dream Chaser is that you get to land at a runway. But like, I feel like that's not really that important. If you could take off from a runway and then land on a runway, that would be something truly revolutionary. But yeah, that's not really in the cards with the current level of technology in the world, I think, right now. Yeah. The space shuttle was better than the Dream Chaser, because at least they reused the main shuttle engines, because the engines were on the shuttle. So that's like the most expensive part. So at least they were able to reuse those. The problem with the shuttle is that it was just kind of too complicated, and it was prone to faults. So it was really not reliable. Like, in just over 100 missions, they had 2 failures that resulted in the death of 14 people. So that's tough to justify. I mean, yeah. It's actually the most deadly vehicle that's ever been created. So maybe not the greatest. Yeah, I would say other rockets were potentially more reliable. Definitely the Falcon 9 is way more reliable. Yeah, we know the Apollo was even more reliable. Apollo had no failures. Yeah, definitely looks cool. I agree. Yeah, coming back to the H3 a little bit. I just kind of wanted to go over a little bit about about some of the engine specifically. If we switch over to the engine that's powering the vehicle, so we have those 2 engines that are at the bottom of the core stage. They're called the LE9 engine. They're actually very similar to the space shuttle main engines. They're simpler in their engine cycle. They're just using like an expander cycle engine. So this means that they're actually using the heat from the combustion in order to power the pumps that drives the propellant into the combustion chamber. So it's actually a simpler cycle than the space shuttle main engines. But they're able to get some pretty high specific impulse with this, and basically make their rocket work. And I actually have some test video footage of the actual tests that they were doing a couple years ago with the engine. So you can see here kind of what it looks like. So here they've configured it exactly like as if it's going to fly. And yeah, you can see there that they use basically just torches to ignite it, because that's all you basically need in order to ignite a liquid hydrogen engine. It's quite easy. But the cool thing about it is that when you look at the actual burn, like, it almost burns clear when you have liquid oxygen and hydrogen, because of course the only product of that is water, and water vapor is actually translucent. if it's not forming like clouds. So you'll see some cloud formations that come off the bottom of it, but if you really look at the engine plume, it will be like almost clear. Yeah. So that's a little bit of a demonstration of what it should look like when they light those engines. So now I want you not to freak out when when the rocket starts, because what's going to happen is those engines that we just saw, they're going to light, and they're going to be lit for some seconds before they light those solid rocket boosters. So it might look like the rocket's not taking off, but give it a couple seconds. They will light those solids, and then the rocket will take off. So yeah, it's a little bit of a patient launch. So yeah, if you're just joining now, we're 36 minutes away from launch. We're looking forward to seeing the H3 launch vehicle take to the skies. It's Japan's next development of rocketry to try to get their payloads into orbit. And hopefully it's going to be cheaper, and it's going to be more reliable, and it's going to be something that will actually commercially compete with some other launch vehicles that are out there, specifically the Falcon 9. I think that's kind of the one they're trying to compete against the most. It's quite clear in their design that this is the case. I think we can just kind of go over a little bit about how they kind of compare to each other. I have a little slide here, and you can kind of see the differences between the two vehicles. So they're kind of a similar height. You can see that the H3 is actually a much bigger diameter. It's 5.7 meters wide, where the Falcon 9 is only 3.8 meters. This is kind of, I think, its biggest advantage. The thrusts are quite similar, and they can deliver similar payloads into different orbits, which is going to be interesting, because that means that they will definitely compete against each other for contracts. Where the H3 will shine is being able to take some slightly bigger payloads into orbit, whereas the Falcon 9 can't really do that as well. So the reason for this is that the Falcon 9's payload has a width restriction, so they can only take things that are only a certain width. So if things are wider, then it can't take it. So a good example of this would be like the James Webb Space Telescope. So of course that could never launch on a Falcon 9 because the width of that payload was too large. But maybe some of those bigger payloads, which are not very heavy but are kind of voluminous, they might be able to fly on an H3 where they couldn't actually fly on a Falcon 9. Or maybe they can fly on both of them, but the H3 just ends up being a bit cheaper, because H3 is actually selling for only 50 million, whereas the Falcon 9 here, today it costs like 67 million, and that might actually not be a modern cost. It might actually be a little more now. I think it's like 70 million or something. So yeah, an interesting vehicle. Will it compete? Well, it'll depend on how reliable the vehicle ends up being, Here you can see a little bit of how they configure the rocket in their assembly bay there. That's actually the payload. So that piece right there, that's the mass dummy that they're going to be flying. It's literally just a piece of metal, and it's just simulating there being 2 tons at the top of the vehicle. So I find it funny the way they've designed it. It's like this long eye-looking thing, eyepiece-looking thing. Yeah, it's basically just simulating the mass in the payload. And my theory as to why it's a big long eye is because they want to kind of simulate that the weight is distributed across the entire length of the payload fairing. If you put all the weight at the bottom, that kind of doesn't quite simulate what a real payload would be like. So that's why it's that like big long piece that you see. I wish they would launch something a little more interesting than just like a piece of metal. Like I feel like there's so many other things that would be more interesting that they could launch. But yeah, that's what happens when you put engineers in charge of of the test launch. Like they could put like some sort of like, I don't know, space monument or maybe a useful satellite, but usually useful satellites are tough to put on the first mission because people are always scared the rocket will explode, and no one wants to put their expensive satellite onto the rocket then. But at least, you know, something a little more interesting than just a hunk of metal would be cool.
天候ですが、少し雲あるもののいい天。
I'm just checking to see if they might switch into English at some point. Sometimes they do switch into a bit of English, leading up to the last little bit of the launch. But for now, you're stuck with me if you wanted English coverage. Yeah, so if you're just joining, the launch is going to be in just over 30 minutes. I think it's 31 minutes now. The plan is that it's going to be the H3 rocket, which is Japan's next launch vehicle, which they've been developing for the last 10 years. They had a test of it last year, but they never got off the launch pad. They ignited those the main core stage engines, and then they tried to ignite the solid boosters, but unfortunately the boosters didn't ignite. So, but that was last year. They've had a year now to fix that problem, and I think they fixed a lot of other problems as well, because that sounds, a year is a bit long for just fixing an ignition problem. There's no scheduled hold right now. It's just the regular plan. They're going to be launching in 30 minutes. I don't think they don't have an instantaneous launch window, so I think they have like 2 or 3 hours that they could launch the vehicle in. So even if they do end up going into a hold, they could recycle. Although keep in mind that if they have touched the solid boosters at all, then you can't hold at that point. It'll be fine. Yeah, and it's also a little more difficult to cycle a hydrogen fueled rocket as well, because the rocket is filled with hydrogen. If you are in a hold, it's like difficult to keep filling and filling and filling with hydrogen, because you have to contain it at minus 250 degrees Celsius, which is like really cold, really technically challenging to do that. So it depends on how the vehicle is configured, how long it can end up in a hold. But don't worry, we're not in a hold right now. This is just normal, on plan. 29 minutes away from launch. Yeah, if all goes well, I would expect that this vehicle could be something that might be competitive against the modern launch vehicles today. So hold on to your hats. Yeah, they do have some broadcast, I think, in a bit of English. They will probably closer to the actual start of the launch, but they're not consistent with that. So yeah, just keep that in mind. It kind of makes sense. I mean, it is a Japanese space agency, so it would make sense that they would broadcast in Japanese. Yeah, if you guys have any questions about the launch vehicle or what we should be expecting, be sure to put them in the chat. I'm happy to answer. I do have a little bit of engineering background, so I can help a little bit at least. Yeah, you might. There's Japanese written on the rockets. You'll at least learn how to count in Japanese, right? They do the countdown in Japanese, so you might learn how to do the numbers.
さん解説ありがとうございました。
Yeah. Would it be possible to invent engines that could use different sorts of fuels? You could invent an engine to pretty much use any type of fuel, to be honest. It's just more of a question of whether it's practical. So I would almost argue that hydrogen and oxygen are almost impractical, but they're like right on the edge of impractical. Like it's like just possible to pull off making a rocket this way. The problem is that dealing with hydrogen is just a complete nightmare, so it's kind of like a really sucky material to try to work with. The only reason why we use it is, and you can see it on the screen there, is because it's efficient. So you get really high specific impulse with it. It can be up to like 30% more efficient than some other stuff. There's other fuels, of course, like methane is also a great fuel source. There's lots of engines that are being developed today that use methane. Obviously, the most famous of that would probably be the Raptor engines. But methane also has its challenges. Probably not quite as challenging as hydrogen, but still a bit tricky. Yeah, are the boosters similar to the American ones? Yes, they are. All solid boosters are basically the same. They mostly just use HTPB. Yeah, it's very similar to the space shuttle main space shuttle side boosters, or to like the Ariane 5 side boosters. Similar kind of idea. They get pretty much the same specific impulse. They fire for about the same length of time. It's kind of the same idea. You can kind of think of the whole vehicle as like a scaled down SLS, actually, because it has the two side boosters. It has a hydrogen, liquid oxygen fueled core. It has 2 stages, but yeah, but obviously it's a lot smaller, and it's also way cheaper. SLS is like multiple billions for launch. This one's only 50 million, so. You want to have an engine that runs with methane and liquid hydrogen. Oh, so you mean like at the same time, or like it could run on both, like either or? Because the issue with that would be, like I guess you could in concept make an engine that could run on both, like it could run on methane or it could run on hydrogen depending on the situation. But like, it's not just the engine you have to think about. You have to think about the entire system, like the tanks and the valves and the pumps and stuff like this. And that you can't really switch between them, because like methane is, how much is it? It's almost 10 times as dense as liquid hydrogen. Liquid methane? Maybe not 10 times, maybe like 6 times. 6 times as dense as liquid hydrogen. So that means that you have to have a pump that is like 6 times more powerful to pump hydrogen as you would use to pump methane. So like you can't really just like interchange the machinery and just have the same results. Again, going back to the point that like hydrogen is way harder to work with, you need to have like way more sophisticated pumps to make a hydrogen engine work. So I don't think you'd be able to just switch back and forth between those fuels. You could maybe switch between different fuels if the fuels were more similar. So like maybe switching between like RP1 or just straight up jet fuel. That might be possible. Yeah, Brian, you have a good point. If you have your fuel and your oxidizer at similar temperatures, it becomes significantly easier to work with. So that's one advantage of methane and liquid oxygen, is that they're stored at roughly the same temperatures, like within 20 or 30 degrees Celsius of each other. So it's very easy to keep them like isolated, or not isolated. If they're not isolated, it's not even really that much of a problem because they're at roughly the same temperatures. Yeah, if you have hydrogen though, obviously it's going to have issues if you're storing it near other things, because it needs to be super cold, and the other stuff might not need to be as cold. Yeah. The other thing you have to think about is like, you can also have fuels that are just stored at room temperature, and that's with RP1 you have that advantage. So you don't need to even like cryogenically cool it. You can just like handle it like regular, almost like regular gasoline. Like, it's much easier. You get less specific impulse, a little less efficient, but it reduces complexity. Yeah, liquid hydrogen needs to be way colder. And you have to think about all the things that brings. Like, you also have to insulate everything more then. So you need to have thicker insulation. Plus you need to have bigger tanks, because hydrogen is super voluminous. It's not dense at all. So you need a much bigger tank. You also need to think about the boil off, because hydrogen, because it's so cold, it boils off much faster. So you actually have losses even like as the rocket's flying, just because of the boil off problem. Yeah. Personally, I'm not a huge fan of the hydrogen and oxygen option, but if you're able to, I mean, if you have the money to pull it off, all the power to you. And if you can do it in a reliable way, that's always good too. But yeah, having core stages that work on it, I think is not really that smart of an option, because like it makes more sense to just power those with cheap stuff, you know. Especially because the advantage you have lower in the atmosphere with hydrogen and oxygen is not actually that high. Like you really get a lot of specific impulse sucked out just because you're burning the atmosphere. And also you have such a low thrust to weight ratio, which is also another problem. But in space it's a lot better. So still good for upper stages. Yeah, ethanol and peroxide. Peroxide is, I don't know, that's also a tricky one to work with because it's always decomposing. So like you could have some peroxide that's like 99% pure, but then if you let it sit for a little while, all of a sudden it's got a bunch of water in it because it's slowly just decomposing into water. So that can be a little bit tricky to deal with on the peroxide side. It's actually commonly used with amateurs though, because it is a oxidizer that you can just have at room temperature, no problem. Ethanol can be a rocket fuel as well. I don't know if anyone has done that professionally, at least not in the modern day. Definitely was more popular back in the olden times when they were just starting with rockets and figuring stuff out. Again, because it's a really easy thing to work with because it's stored at room temperature. At the start, they were doing everything at room temperature. Yeah, I've never actually looked into the peroxide catalyst rocket design. That would be a curious one to look into with the silver catalyst. That's interesting. Yeah, and it's interesting to like. I wonder if that would actually be a really cheap option for launching. Like if you scale it up, like could you actually make a launch vehicle that runs on peroxide? Like would that be reasonable? Yeah, the V2 was famously ethanol. Yes. Yeah, they used to use alcohol in rockets a lot more back in the day. Obviously, it was a lot more available to them at the time, right? Was the X-15 actually peroxide? I didn't know that. I thought the X-15 was something else. Do I think Europe should offer more launch sites? Europe doesn't actually offer a launch site yet. So more than one would be nice. The only launch site that Europe has, which technically is in Europe, is the one that's in South America, in French Guiana. That's where Ariane launches, but I don't think that really counts as a European launch site. That's like a South American launch site that Europeans use. But there's no real mainland launch site. There are some that are coming online maybe. So there's one in Norway that might come online. There's a couple in the UK, specifically in Scotland, that might come online soon. But I don't think they'll really get high launch frequencies, to be completely honest, because like getting to those places is really, really hard. Like they're not connected to like the infrastructure of transport. Yeah, the one in Norway is like way up in the high latitudes, and the ones in the UK are like way up in the random spots in Scotland that you need to take like some random tiny little road for like hundreds of kilometers to get to these places. So I kind of am a little skeptical about how much they can really scale up launch operations in those places. Yeah, one of them is the Saxford in Scotland. Yeah. There's also another one called Spaceport 1. That one's also in Scotland. Yeah, they're great. All these launch sites, by the way, are fantastic for student rockets. Just saying. It's like the perfect thing. It's the middle of nowhere. You're not going to hit any houses or anything. So So for those purposes, they're fantastic. But for, I think, professional rockets, it's a little tougher, you know, because you kind of need infrastructure. That's like an important part of the whole development process. What happened to the launch site of the Red Arrow rocket? I don't actually know the Red Arrow rocket. Who was developing this one? Is this a German rocket or the UK? Is this a British rocket? Yeah, I think I know what you're talking about. They actually launched that in Australia. They didn't actually launch it in the UK. The UK never had it. The UK never had a launch site. There was one launch vehicle that they used to have, and they launched it. They launched it out of Australia. Australia also has some good launch sites. Obviously, they have lots of empty space, right? So that is their advantage. But yeah, I'm hoping there'll be more launch sites that open up in mainland Europe. One place that would be fantastic would be if they open up a launch site like down in the south of Spain that launched over the Mediterranean, like down by Gibraltar. I think that would be a fantastic launch site because then you're getting like a lower altitude, a lower latitude, and you can do eastward launches. You can't really do that with the northern launch sites because they're so far up north that the only launch direction you can really go is north or south. So you can do like the polar orbits and some really highly inclined orbits, but you can't get those like close to equatorial orbits. Of course, you won't get that with Spain either, but you're at least getting something that would be akin to launching from like Florida or something. And you also have a bunch of open water that you're launching over. So like it kind of makes sense as a launch site. But for some reason, that's like not a thing that's ever really been developed. But I think that's a hidden opportunity. What do I think about the electron recovery methods for Rocket Lab? Well, I don't think they've ever tried to recover again since they had their first heli recovery. I think that's telling in and of itself. Yeah. Basically, I think that the complication of trying to catch it in the helicopter was too complicated. And it doesn't really pay off very well in terms of because you have to spend a bunch of money to make that happen, and so by then you could have just like built another core stage, so it doesn't really make sense. I think that was kind of the issue they were running into. And yeah, of course, if the booster ends up in the salt water, I think that's kind of a big problem because the struggle is that like the engines and the structures, they will get degraded basically if you do that. So yeah, I don't know if it'll be flight worthy at that point. Why can't they catch electrons with a ship? I mean, it would be interesting if they could like land it on a ship. I think that would be something that might be possible. But the problem is that there's not enough reserve capacity on the Electron to actually have it come back. It's like right on the edge when it flies to orbit, and this is actually really evident if you look at the vehicle itself. Like it's very small for its mass that it lifts. It's like one of the smallest rockets that's currently operational. So it doesn't have a lot of payload capacity. So if you try to add recovery features to it, then you're reducing the payload capacity. And if you want to make it so that it can actually be fully recovered properly, you end up at a payload capacity that's like nothing. And then you're not getting any payload to orbit, so then it kind of kills the project right there. Really what they have to do is redesign Electron. And so that's what they're doing. They're making this new vehicle called the Neutron, and that's going to be a fully recoverable vehicle. So I think the Electron is not really a good vehicle for doing recoveries in general. And I don't think they're going to really I don't think they're really going to pursue it in any meaningful way. they did the testing, and I think that taught them some things, and then they're going to use that to inform how they design Neutron. I mean, that even makes sense from a like an economic and business perspective. Yeah, I mean, if they can reuse the engine, of course they will. So, yeah, I just don't think they're going to be able to reuse like the engines like SpaceX does, you know, where they just pop them out and they can reuse an engine like 20 times without refurbishment, which is basically what SpaceX is doing, and that requires an engine that doesn't go into the ocean, I think. Yeah. Here we're seeing on the screen an animation of how the launch is going to go. I'm hoping they have some nice cameras on this rocket so that we will actually get to see some of these views. You also see the mass dummy there. They're also going to have they also have two small satellites on there that are doing a little bit of a ride share. There's one CubeSat and one that's slightly bigger. But the main thing is that weird eye looking thing at the top there. That's the mass simulator. Don't worry, they're not going to leave that in space. They're going to deorbit it and bring it back down, so it won't cause space junk or anything. How does SpaceX cool the engine bell? Well, it depends on which engine we're talking about. For the Merlin engines, they use the fuel, the RP1, to cool the engine, so it's liquid cooling. That's for the core stage. For the upper stage, the big engine bell actually doesn't have any cooling at all. It's just radiatively cooled, so the metal just gets hot, and it gets hot enough that it radiates enough energy away that it doesn't melt. For the Raptor engines, they are also using liquid cooling, so they're using fuel. I think they're also using oxidizer. I could be wrong about that, but they're definitely using fuel. They're using methane to basically cool the engines, and they're running that through the bell and keeping them cool. And I'm not sure about the upper stage Raptors. I think that's not really. I think they're just using the same strategy of using radiation cooling on that for the big bell. But we've never actually seen those fly yet, or we did. We saw it in the I guess we saw it in the flight test. I guess they turned them on then. Yeah, there's definitely huge mass economies that scale up once you go to a bigger rocket, and you basically allow yourself to build yourself enough of a payload buffer that you can add recovery features. And honestly, if you just look at the bare bones of a rocket, you need to have a rocket that's operating with payload capacities in the tons to be able to start thinking about doing a proper recovery. So, like, if you're in the Electron range where you just have a couple hundred kilos, you really don't you can't recover a rocket with just a couple hundred kilos. You know, it takes more than that. Yeah. Starship point-to-point flights. I don't think that's going to be a thing, to be honest. It's just a little bit ridiculous. Maybe the military will use it because they have money, but I don't think it's going to be feasible, like, for people to do that. And plus, it needs to be so reliable. Like, if you're going to put people on it where they're just flying it like an airliner, it needs to land every time. Like, that thing can never explode. And I don't see them building up a repertoire of reliability like that before 2030. So if it is something, it'll be something that opens up after that, I think. Yeah. So we are now just 7 minutes away from the launch. You can see here we're really zoomed in on the payload fairing. With you can see the ocean on the side there. The rocket launches off the east coast of Japan, and of course it's going to be flying towards the east. And it is actually quite a nice location. It's up there on like a kind of like a cliff interface there, so it looks pretty cool.
Range safety system is go.
Ah, we have some English.
Range system is go.
So maybe if we listen to both the English and the Japanese, we can learn some Japanese. How about that? So it's just like the sun has just risen in Japan. It's like first in the morning. Perfect weather for a launch. It looks like they don't have much wind. All those clouds and puffs you see coming off the rocket are the condensation because of the cryo cooling on both the hydrogen and the oxygen that they put into the vehicle. So. Yeah, it's I don't even know how to say this properly, but it's Tanjin-shima. That's the launch site. Yes.
現在車上の天候は晴れ、気温摂氏14.4度、北北西の風、毎秒1.9メートルです。
It's
It looks like
6 minutes to launch. The current weather at the launch site is fine. Temperature is 14.4 degrees Celsius. Wind is 1.9 meter per second from the northwest. The weather is still a go, and currently there is no constraint for launch.
So this is good to
本
hear.
日の打ち上げ予定時刻は日本時間の午前9時
Looks like everything's a go so far.
秒です。
No problems, no
Today's
holdups.
schedule lift-off time 9:22:55 seconds a.m. Japan Standard Time.
Just 5 minutes away now. What I find interesting about the Japanese launches
5分前です。
is that they always have that Japanese lady counting down for like 10 minutes. She's always in the background just counting down, counting down, counting down. It really adds a little bit of drama to the countdown process, I think, when they start so soon. I can promise you there are differences. So yeah, we're just 4 minutes away from launch now, and they've started the countdown. It's a Japanese launch, so they always start the countdown quite early. It's not the same as we would usually do it, where we start from like 20 or something.
自動カウントダウンシーケンス開始。
So far, the weather is good. The
現在
range is
ロケット
good.
の管制は竹先発射管制塔
There is venting. You can. The problem is the sunlight is like exactly in the wrong spot, so you can't quite see the vent clouds coming off. But it is venting, and it will be doing that right up to launch because these fuels need to be held at very cold temperatures, minus 250 for the hydrogen, and I think it's like minus 200 for liquid
2段
oxygen.
液体水素地上油圧開始
I mean, it is 63 meters tall. Could be like Godzilla. But hopefully it's not going to destroy any cities today. That would be bad. Yeah, it's the insulation they're using is the same spray-on insulation that the shuttle used. It's very common for hydrogen fueled rockets that they use that. I think,
3分前です
yeah, it's quite ubiquitous.
1段液体
Are you sure it's cork? I'm pretty sure they use a spray-on insulation. The cork would be way too heavy.
Has been initiated.
機体の電源が外部から内部に切り替えられました
The power has been switched to the internal system.
Okay, we're getting close here. So just to remind you guys, they are going to fire the core boosters first. Those are there's two rockets, two engines at the bottom. those are running on liquid fuel. They're going to burn for a couple of seconds before they light those solid rocket motors. Once those solid rocket motors light, it's going, and there's no going back. And those boosters are going to burn for about 100 seconds, and then they're going to separate, and then the core stage can carry on its way. I hope we don't get a rapidly unscheduled disassembly. I'm pretty sure that they'll get this one right. I have great faith. And yes, the flamey end is down. The pointy end is up.
has been initiated.
All is configured correctly. Hopefully they didn't switch any valve or sensor positions. It's often a common issue with rockets. Yeah, I think it's going to make it. I have great faith. There's been a lot of engineering on this.
1 minute to launch.
10 years of development. And it all comes down
フレーム
to
デフレクター冷却開始
Flame deflector cooling is initiated.
Alright, get ready for those main engines coming on.
ウォーターカーテン散水開始
Water spray system at the launch pad is activated.
So they've just started their water deluge system. It's going to help them to dissipate the shock of the rockets igniting.
Flight mode on.
加工品トーチ点火
Hydrogen purge igniter on.
Here they
全シ
go.
ステム発射完了
All systems are go
Engines
forward.
メイ
firing.
ンエンジンスタート
Main engine starts.
And the rocket's fired. All right.
点火リフト
We're
オ
in
フ
flight.
Solid booster ignition and lift off.
Here we go. That thing has a lot of
元気
thrust
に動
away.
きは2024年2月17
Very
日
quick takeoff.
午前9時22分55秒に種子島宇宙センターから打ち上げられま
Oh,
し
this is
た
looking great.
We have a successful lift-off of H3 launch vehicle test flight number 2 from Jaxa Tanegashima Space Center
I see that it's
at
starting that gravity turn now.
9:22:55 a.m. on February 11th, 2024, Japan Standard Time.
打ち上げ以降ロケットの完成は竹崎発射管制塔から竹崎総合司
Man,
令
the
塔
sounds
に
coming
送ら
off
れ
this
てい
thing
ま
are
す
just crazy.
The operation control of H3 has been switched from launch control center to range control center.
ロケットは現在東南東方向の太平洋上へ飛行しています
H3 is now flying above Pacific Ocean to the east southeast.
打ち上げ後1分が経
So
過し
they've
ま
just
した
passed max 2
11
now.
minutes into flight.
So that was the point of highest structural load, and they just got past it. So the launch vehicle itself is definitely strong. But yeah, these engines make quite a whistle sound, I have to
ロ
say.
ケット追尾状況も正常です
This is a very unique audio signature.
And the ground stations are tracking the launch vehicle and all is good.
So we should see those solid boosters coming off in 10 or 20 seconds now. And you're just going to see them just pop off the side, and they're going to separate and fall away, just like they would for the SLS or Space Shuttle or something like that. And none of this is getting recovered, it's all just getting extended. It's not a recovery launch vehicle. And there you see the two boosters just separated, and now they're coming back.
Solid booster separation.
They're not coming back, they're falling
ロケット
back.
は現在種子島内之浦の支援部から追尾されています
Currently, Tanegashima and Uchinoura ground stations are tracking H3.
Okay, it looks like we have gone beyond visual range.
第1段エンジンの燃焼は正常制御系飛行経路も正常です
The conversion of the first stage engine, attitude control, and trajectory are all nominal.
ロケットは順調に飛行を続けています。
The H3 flight is on course.
So it looks like everything is on course. Yeah, so it looked like it was making a turn. I mean, it does take a gravity turn, and you can see that that's what's happening here on the animation. This is giving you live telemetry data, so it's at least giving us that. It looks like they don't have an onboard camera, unfortunately, which is sad. They should definitely think about that more often. But you can see in the left-hand corner they have the speed going up. They're at right now 6,700 kilometers per hour. They need to get up to 28,000
衛星フェア
kilometers
リ
an
ン
hour.
グ分離。
はい、今衛星フェアリングの分離までが確認できました。
はい、
H3 ロケット試験機2号機打ち上がりましたね。
はい、今のところ順調ですね。
And you can also get a sense for the trajectory. I think they have, in the top there, they also have the altitude, so they're up to about 150 kilometers.
ロケット用のフライトステータス
But yeah, the key number to look for is on the left there, which is the speed ticker. Yeah, we should see that get up to 28,000 kilometers an hour. If that starts to have issues, then you'll kind of get an idea as if something is going on with the
データを
vehicle.
もらってですね、ここに反映しているので、本当にロケットが飛んでいる方向を表しているもの。
Yeah, I don't know. I guess once again you're at the mercy of the engineers. You know, it's not so important the broadcast of the launch to the world
これが速度を表しています。
in their
速
minds.
換算なので、
I'm sure they have lots of engineering cameras, but they're always reluctant to show those. You know, what if something goes wrong, and then you don't want to publicize that mistake on a live stream anyway. But yeah, that launch looked pretty much perfect as far as I could tell. Everything happened in the time that it was supposed to. The solid rockets burned perfectly for their 110 seconds that they were supposed to burn for. Then they separated cleanly. And the core stage continued on its way to orbit. So, at least we know that the rocket's working properly. I agree with you, Tom. The cameras should be mandatory. They should make it like a requirement. Like, you can't fly to space unless you put a camera on the rocket. That's a requirement. If you don't have it, then no go.
黒い点になって通過するイベントを通過すると黒い点が残るんですけど、これ残っているということはちゃんと分離とかですね。
So if you see the numbers now ticking down again, that's because the rocket is staging right now. So it's just let go of the core booster, and we should start to see the numbers start to climb again if we get a second stage ignition.
そうですね。だいたい16分36秒。
But this is a very long,
次のイベントまで少し
a long second stage ignition. I hope that it's going to ignite. Come on, baby! Don't fail on the ignition. I gotta see what they're saying
終
here.
了まで無事に完了してデータもきちんと取得できれば今回の飛行実証の目的達成とい
We
うこ
should
と
see
になり
that
ます。
number in the
まあ
left-hand
ロケッ
corner
トと
start
し
to
ては
climb
そう
again.
ですね。まずは実証できたということになり
But
ま
it
し
looks
て、
like that's...
で今
Oh,
回
here we
の
go.
機械
Is
を
it
利用
coming
して
up
です
now?
ね、2つの小型衛星というのも相乗りで搭載させていただいてますので、この衛星の分離というのも、もう一つの重要なミッションにはなります。
To be honest, I think there's
2
something...
段分離した直後にですね、
I think there might be something wrong with the second
CSAT-1E
stage
の方が分離をして、
So we should be
その分離信号を確認できますので、
seeing
そこまでしっかりと見守って
Or
いき
no,
たい
actually,
というふうに思ってま
I
すね
shouldn't。say that. The number's
はい
climbing back up again.
そして
The engine is on.
改めてこちらのピップの見方に
No,
つ
not
い
to
て
fear.
解説をしていきたいと思います。小谷さんお願いできますでしょうか。
はい、
打ち上げ後7分
打ち上げ場所、
経過しました
種子島からですね、線が伸びているんですけれども、各黒い点にイベントが書いてます。これは1段の燃焼停止とか2段の
So,
燃焼開始とか、
I think
そういうイベン
everything's
トが
okay
書い
right
てま
now.
す。で、この
There's
先
actually
の
a
方に
very
も、イベントがあって、
curious thing
しばらく
about
後なの
the
で見え
way
てないん
this
ですけれど
rocket
も、
is
またイベントが近づいてくる
trajectory
と、
oriented
目
and
で見てわかるよ
even
うに
trick to
な
me.
ります。で、
What
左上
happens
が
is,
速度ですね。
because
今12600
Because they have such a low thrust to weight ratio on the liquid hydrogen and oxygen stages, their trajectory is very vertical at the start of the launch. So if you see there on the the altitude tracker, they're already at 570 kilometers, and they're, moving at like a kilometer every second upwards. And the reason for that is that that second stage is so weak that it needs lots of help to, it doesn't have enough time, basically, to push itself into a circular orbit if it was on a flatter trajectory. So they actually have to, like right now, the engine is, they're not facing parallel to the Earth when they're burning. They're actually burning at an angle to their trajectory. So the rocket's kind of side sliding like this. If you ever played KSP and you have a very low thrust to weight rocket, you'll know what I'm talking about. So you have to kind of point the rocket more up to make up for the fact that you didn't get enough apogee at the start. So that's kind of what the rocket's doing right now, which is why that horizontal velocity was not actually going up very much. But you'll see that as the burn progresses and they get to higher point in their closer to their apogee, they'll start shifting and getting more horizontal, and you can already see that the horizontal velocity number is starting to tick up a lot more rapidly. But at the very start of that burn, they're like really kind of in a weird position because they're trying to make up for the fact that they don't really have that much thrust to weight ratio. This is actually another disadvantage of the hydrogen-oxygen architecture, which is that maneuver actually sucks delta V out of the rocket. So even though you have a more efficient engine, because of the fact you have a low thrust to weight ratio, when you're trying to get to low Earth orbit, you actually have to pay a delta V penalty because of the weakness of the rocket, just because you're losing it on the trajectory itself. Yeah, I'm sure there were a lot of nervous engineers, me being one of them. I was aware that was going to happen, but like I didn't realize it was going to be so extreme. It's even worse than the Ariane. The Ariane also kind of has the same issue, but it's a little more powerful, so it doesn't quite have such an extreme startup transient.
していきたいと思います。今放送がありましたね。
But yeah, it looks like things are still going pretty well. You can see that the altitude is no longer ticking up quite as fast, so we're getting closer to the apogee of the burn.
The combustion of the second stage engine achieved control and trajectory are all nominal.
Yeah. The Saturn V was a little bit different of a vehicle, though. It actually got to orbit a hell of a lot faster. And the reason for that is because it was carrying humans. You actually can't do these trajectories with these low thrust to weights with humans, because you end up going on really vertical trajectories at the start. The problem with that is that those are very unsafe, because if you go kind of at a really steep angle at the start, if there's something wrong and you have to abort, you have to come back on that steep angle, and those recoveries or aerodynamic reentries are way more extreme, and you end up with 10 G's of force for like a minute. And humans aren't really designed to handle that kind of G-force. So usually when they're doing missions for humans, they will never do this, and they will go on a more flatter trajectory. It's kind of more like a Falcon 9. Falcon 9 is actually perfect for humans. It's a very comfortable rocket to fly on.
だんだんこう多様化っていうか、いろんな形の人工衛星、が出てきてですね、でかつですね、やっぱロケットの市場っていうんですかね、ビジネスの市場、この競争力が非常に激しくなってきて、価格競争。
So we are about 2/3 of the way there now. You can see we're at about 17,000 kilometers an hour. We're going to be building up to 28,000 kilometers an hour. So still a bit to go. You can also see that our altitude is no longer really ticking up much. It's actually going downwards. But don't fear, this is planned. Another consequence of this strange trajectory that we're on is that actually while you're going to orbit, you actually end up having your vertical altitude come down. But they're still on trajectory, don't worry.
ポイントとなるのがですね、 H2A は、まあ、コア
That's true.
真ん中の機体
You're right. There is an extra advantage of the shuttle, which is that you have low re-entry force.
はそのコアだけで
But I would argue that the difficulty of having a shuttle re-entry is also a bit of a struggle. Because like if there's one tile that is not correct, then the whole vehicle melts. So that's not nice.
増やしていき、かつですね、LE9 のメインエンジンも2つ3つと変えられる、自在に変えられるという、まあ、そういう特徴を持っていてですね、どんな、まあ、重さの衛星でもですね、まあ、その衛星に合わせて形態を変えられるという
So we
の
have
が
about
特徴になっていますね。
I think we have about 3 minutes left in this burn.
今の
It's a really long burn
を見ていき
when
ましょ
you're
う。
dealing with
今のところ
liquid hydrogen and oxygen.
ここは
Usually they burn for like, 10 minutes.
このところそうですね、まあ、速度も上がってますし、
はい
高度も維持して
If you compare that to like amateur rocketry, usually we burn for like maximum 10
あ
seconds.
と
It's
2
such
分
a
ほどで
different world.
そうですね。
第2弾エンジンの第1回燃焼停止の予定です。
Were there astronauts standing up during shuttle reentry? I don't think that was allowed. Surely not. I feel like that's very dangerous. 2Gs is still a lot to stand up in.
もう楽しみですね。C サット 1E の方は
If you ever experience 2G,
そうですね、この
yeah.
第2弾エ
Not
ンジ
something
ン
you want to be
第1回燃焼停
walking
止の
around
直
in.
後に
そうですね。
予定されています。この CSAT-1E にはJAXA が開発
They
している
don't
マウント
use the reusable
と
tiles
いう
on the
も
Crew
のがつい
Dragon
ている
because they're less
ということで
reliable.
したが、
Uh,
これ
like it's way cheaper and easier to just use the ablative materials. Like and it's like tried, true and tested. You know, the tiles. There's always a chance one could fall off, and then yeah, if you don't have a tile, that's that's going to be a problem. You can see it on the starship. You know, they lose tiles on every single launch. So tiling is always a struggle. You know. But yeah, we're getting close here to. We're getting close to finally getting to orbit here. We're at now 23,000 kilometers per hour. Target is 28,000. So we are nearly there. This is looking really positive. I think this is going to be a fully positive mission. This is technically its first flight, so they're nailing it the first time. The last time there was a problem just on the launch pad, so the rocket never took off. So this is actually quite unprecedented. Usually it's taking some time before you get a launch vehicle working properly, you know? Yeah, I wouldn't classify Crew Dragon as fully reusable. Like they definitely change out a lot of stuff. So yeah, like they changed the heat shield. I'm sure they make other little refurbishments. So it's not like it's not fully reusable like their boosters are. You know. The trajectory right now is not polar. It is basically they just took off straight east from Japan. But because Japan is having such a high latitude, that puts you on a very inclined orbit. So it's like inclined at 50 degrees or something. So yeah, they're basically just flying the most efficient trajectory that they can. And it looks like they have just shut off the engine. They're now at 27,000 kilometers an hour. I think that is correct. People are cheering, that's a good sign.
無事 CSAT-1E も分離が確認できたようです。CSAT-1E が H3 で軌道に投入された最初の衛星となりました。
The engineers are happy.
やりましたね。なんか感動しますね。
はい。
これをもちまして H3 ロケット試験機2号機の打ち上げ実況放送を終了いたします。
We will now conclude our live coverage of the H3 test flight number 2. Thank you.
All right, that was a fantastic flight, and for it to work on the first try is definitely a positive.
はい、改めて無事2段エンジン第1回
Super awesome. I'm glad they pulled it off. And I'm looking forward to how this vehicle ends up in the future. Like, I would love to see more and more flights coming out of Japan and out of other places in the world, because it shouldn't just be SpaceX and America that's launching rockets. There should be more coming from the rest of the world, you know? So this is all positive. I'm really enjoying this. Yeah, I'll stick around. I'll answer a couple more questions here. So here we have a question about why doesn't SpaceX clean their boosters? Well, that's actually a good question. They should clean the boosters, is the answer. But the thing is, it doesn't really matter that much. So, like, in the grand scheme of things, I don't think that, like, you add a little bit of weight because there's a little bit of carbon that's ending up on the side of the booster, but, like, it doesn't really matter in the end. Like, we're talking some, maybe if you clean the whole thing, you might take off a couple kilograms, but for their, mass budgeting, it hardly matters. So it's probably not worth the energy to do it. Yeah, I'm not sure what it means for their thermal, because it does change the thermal properties of the booster. But it clearly doesn't matter that much because they don't clean them. Yeah, I don't think they'll ever do that. And I think they look cooler with the soot, you know? They look like flight proven, like they've been through some stuff, you know? So I think it's good that they have it. It shows character for the rocket. The rocket's got to have a little bit of soul, you know? All right. Well, I hope you guys had a good time checking out the launch of the H3. I'm looking forward to seeing more launches of that vehicle, as I said before. I want to see them potentially stealing some business away from SpaceX every once in a while. Because we got to give SpaceX some more incentive to get their costs down. Because I feel like they came to the markets 10 years ago and they have this beautiful, $62 million price, but they haven't really improved that much since then. You know, they've had no reason to. So I'm hoping that the more competition in the market is going to force them to kind of reevaluate the access to space and the cost of the access to space that they deliver. So I look forward to that process. Anyways, thanks for joining along, guys, and looking forward to seeing you in the next one. Be sure to stay tuned to the channel because we have some interesting videos that are coming up. More specifically, the video about our attempt to launch our rocket that was back in last October. So we finally managed to pull the video together. So check out that if you're interested. And yeah, we're doing some cool stuff next year, or this year now, I guess. For our next rocket, and you're going to want to check out what we got planned. Lots of cool stuff that we're designing. All right, then until next time, I hope you continue to expand your horizons.